Assalamualaikum and very good day. Today I would like to present my research mainly focused on neuroprotective effects of BDNF against retinal injury and visual impairment. Glaucoma is a disease caused irreversible blindness and projected to affect more than 76 million in 2020 and 111.8 million in 2040. Studies have reported a deposition of amyloid beta in Alzheimer's disease also have a possible immunological pathway of RGC destruction. Amyloid beta accumulation and tau hyperphosphorylation causes neurodegeneration of RGC in glaucoma patient. Inhibition of amyloid beta pathway reduce glaucomatous RGC loss. In glaucoma patient, there were decreased level of BDNF in retina cause neuronal death. Amyloid beta decrease the BDNF mRNA expression and lead into decreased activation of TRKB receptor cause impairment of BDNF signaling. BDNF is a chemical produced by brain, function in dendrite growth and stimulate neurogenesis. The objective of this study aimed to investigate the neuroprotective effects of BDNF against amyloid beta 140 peptide, induced retinal injury and visual impairment in Sprague rats. In this study, rats were categorized into three groups: control, 140 group, 140 co-injected with BDNF, and rats were subjected to 5 different parameters. First, we want to observe the effects of retinal injury using H&E staining. From this study, we found out that 140 group shows significantly lesser number of retinal nuclei as compared to BDNF and control. Further assessment were done using retrograde labeling where we injected fluorogold staining, and we found out that in 140 group, lesser number of live retinal ganglion cells were observed as compared to BDNF and control. The apoptotic signal using tunnel staining also shown similar result, where 140 group express higher number of apoptotic signal as compared to BDNF and control. Next, we move into optic nerve damage assessment, where we found out that in 140 group, number of nuclei condensation and speculation were significantly higher as compared to BDNF and control. Similarly, when we observe the oxidative stress marker and BDNF concentration using ELISA, we found out that in 140 group, the activity of SOD, GSH, catalase, and BDNF were significantly lower as compared to other groups. When we proceed into the object recognition test using open field arena, where first rats will undergo the familiarization stage, where they will introduce with 5 novel objects, proceed with first partial test, where object 4 and object 5 location were displaced from its original location, and object 1 were replaced with object 1A. And from this study, we found out that during familiarization stage, there are no significant difference between all groups. However, the condition changed when object 4 and object 5 were displaced from its original location, and it caused amyloid beta 140 group remain significantly high number of approaches to object 1, 2, and 3 as compared to other group. And when we replace object 1 with object 1A, amyloid beta 140 shows significantly high number of approaches to object 2, 3, 4, and 5. Then we proceed into Morris-Water maze, where we use this study to evaluate visual impairment in rats. And from this study, we measure the time taken of rats to find the hidden platform. And from this, we found out that 140 group show significantly longer time taken to find platform as compared to BDNF and control group. On the right side, show the trap plot of rats in Morris-Water maze. Next, we proceed into expression of Western blot and PCR. We measured TRKB, ERK1 and 2, and caspase-3. For TRKB in ERK1 and 2, 140 group shows significantly lesser expression as compared to other group, while for caspase-3, the expression of caspase-3 was significantly higher in 140 group as compared to other group. Hence, this study showed that amyloid deposition will lead into calcium influx and lead into activation of calpain. Activation of calpain will lead into cleave of the RKB receptor and lead into decreased expression of BDNF. Activation of calpain also will lead into dysregulation of CDK5, phosphorylation of tau, and formation of neurofibrillary tangle. At the same time, overactivation of calpain will lead into production of caspase-3. With the help of superoxide and ion, it will eventually cause neuronal death. Superoxide and ion will not be able to regulate to its normal condition due to low number of SOD, low GSH, and low catalase activities. However, with presence of BDNF, it activates the RK1 and 2 pathway and increase production of BDNF expression, and preventing activation of calpain and dysregulation of CDK5, lead into preventing of phosphorylation of tau and formation of neurofibrillary tangle. At the same time, BDNF will regulate the calcium influx and prevent the production of caspase-3 and eventually prevent the death. Superoxide and ion will regulate with increased number of SOD, GSH, and catalase. Hence, this study did prove that 140 induced rats did develop retinal and optic nerve injury, and BDNF prevent retinal cell apoptosis caused by 140. I would like to thank my group, and for that, I would like to say thank you.